Good morning again. I am Dr. P.S. Kaushik, Principal at Sri Digambar Institute of Technology, Dosa, Rajasthan. This is my additional lecture on basics of moment of inertia. This is a topic under the subject engineering mechanics belonging to third semester of civil and mechanical engineering. Here I will be dealing with the practical application in the real world of this principle of moment of inertia. That is moment of inertia, how it is dealing real world situations. Okay. Now quick note on the CG or centroid again. It is a repeat of lecture 26, because the center of gravity is one of the factor very important for moment of inertia. So the centroid or center of gravity of any object is the point within or outside the object. The outside is missing here, from which the force of gravity appears to act. An object will remain at rest or it is balanced on any point. An object will remain at rest if it is balanced on any point along the vertical line passing through the center of gravity. So it indicates that the position of center of gravity will remain unchanged irrespective of the orientation or position of the body. The centroid of a two-dimensional surface, two or one-dimensional surface I can say, is the point that corresponds to the center of gravity of a very thin homogeneous plate of the same area or shape. If the area or section of a body has one line of symmetry, the centroid will lie somewhere along the line of symmetry. Again, if the area or section of a body has not only one, if two line of symmetry it has, then the line of cross section of the line of symmetries will be the centroid point of the section or the body there. So it means if left part of a body about that axis is the mirror image of right part, then that is a line of symmetry. And if it is in the two dimensions, then the cross section of those two line of symmetries will be the point of center of gravity or centroid. Then what is moment of inertia? It is a measure of an object's resistance to change to its rotation. Basically, it is similar to the inertia for a rectilinear motion. For a rotary motion, we call it moment of inertia. And inertia is the property governed by the mass of the object. And the position of mass about the axis of reference. How much distant it is. More is the distance, more will be the moment of inertia about that axis. Also defined as the capacity of cross section to resist bending. It is for structural engineers that a section of a member, that a beam or a column, has to be such that the bending moment is resist maximum by making the moment of inertia about that axis maximum. That will be dealing more when we are dealing with the numerical problems and derivations for various cross sections in the lecture, in the coming lectures 2 and 3. It must be specified with respect to the chosen axis of rotation. It is quantified in the units of meter to the power 4 for section moment of inertia and kg meter square for the mass moment of inertia. Then moment of inertia, again, as we know that turning effect of a force is called moment, and mathematically it is equal to the product of force and the shortest distance vertical from the moment center on the line of action of the force. Moment of force, force into vertical distance x, Newton meter is the unit. If you multiply this moment again with the shortest distance x, then it is called moment of moment. And if you replace this force by mass or area of a section, then we will calling it mass moment of inertia or section moment of inertia. The mass moment of inertia unit becomes kg meter square, and section or area moment of inertia, the unit becomes meter to the power 4. Now real world application. The real world application of moment of inertia. First, you see the engine. This is an engine. This is engine with a fan to pump the water out of well. This is driven. This is the engine part in details. This is the inlet valve. This is outlet valve. This is the valve, poppet valve. Poppet valve means you can say the mushroom head valve, or its shape is just like a plant mushroom. Its shape you will find it is like this. So we call it mushroom head valve or puppet valve. Puppet valve means it is a puppet of valve timing mechanism. As the crank rotates, it rotates. It is due to this crankshaft, a camshaft we are calling it. So here, what is the function of this flywheel? This is a 2 flywheel. This is a single heavy flywheel, and you will find that this is having the 3 wave sections, and whole mass of this flywheel is on the periphery of this wheel. Why? Because you can say I equal to mr square. So the I is proportional to r square. So जितना भी मास जो है पेरीफेरी सेंटर से दूर होगा उतना ही ज़्यादा इसका मोमेंट ऑफ इनर्शिया होगा. That's why we are keeping maximum mass on the periphery of the wheel, just for the integrity of the wheel, so that it should not break from the axle. We are keeping just these 3 flanges to keep it strong enough to resist the centrifugal force caused by the rotation of the wheel. This, when this wheel is rotating, there will be a centrifugal force acting outwards. So the wheel should not get broken due to this force, centrifugal force. That's why what we are doing, we are just giving sufficient material for in these 3 webs, and remaining mass we are moving outside on the periphery. Jitna maximum distance it should be away from the axle, but due to the engineering problems, that is obstructions and other engineering parameter problems, we have to keep some distance, this diameter of this wheel within limit. Achha. Now what is the purpose of this? This is a 4-stroke say diesel engine or 4-stroke petrol engine. You say it is a 4-stroke petrol engine which is in your bike. You are using it. in the 4-stroke means 1 stroke from top to bottom. This is on crank rotation is it has reached from here to here, means 180-degree rotation from top this position to this position. Crank has moved from here to here, and the total rotation is 180-degree in first stroke. Then second stroke, the crank is moving like this and piston is moving upward. This is your again plus 180-degree, means total is one rotation or 360-degree. Again one more stroke like this downward, then plus 180, and then again one stroke like this, that is plus 180 again. So total rotation is 720-degree or 2 revolutions to complete one cycle of the piston. Here in first stroke, this valve is closed and the air fuel mixture is entered here like this, and this piston reaches to this level. Again both valves remain closed, and second stroke the air fuel mixture is compressed. It has reached to this level again. Here is high temperature, high pressure mixture is here, and then a spark plug is available here. It is obviously a petrol engine. So a spark takes place, and next the third stroke is the power stroke. After that the power is achieved, then next the burnt gases are to be exhausted out. This is the fourth stroke, which is going outside exhaust gas. So now a little consideration here will show you that the power you are getting only in the third stroke. First stroke is inlet intake stroke, then is compression stroke, then is power stroke, or then is exhaust stroke. So 1, 2, 3 and 4, you are getting power only in this power stroke. Then how to run this engine continuously? How, from where should we get the required power to complete first stroke, third stroke and fourth stroke? Power or energy for these three strokes you are going to get from the flywheel. This flywheel will give you the energy for remaining 3 strokes, because you are getting power only in power stroke, that is stroke number 3. Again, how the energy is stored? I omega square. This is the energy stored, kinetic energy stored due to rotation of this. More is the I, more will be the energy stored, and more is the angular rotation, more will be the energy stored. So you are getting energy for the rotation or continuous rotation of the engine for the 3 strokes, that is intake stroke, compression stroke and exhaust stroke. Now here you are finding this flyweight. What is this? It is a balancing weight to counterbalance the weight of the big end of this connecting rod and the crank. Otherwise, if this is not there, then there will be engine vibrations. To balance that, there is a flyweight installed just opposite to the crank side of the connecting rod on the crankshaft. I think this much is sufficient for you to understand the importance of flywheel in the engine, IC engine or internal combustion engine or external combustion, both. So it is sufficient for you now. Again we will be discussing in details in another classes. Now gyro horizon or artificial horizon, very important in aviation, especially for the fighter aircrafts. This is we are taking use the advantage of the property, that is inertia, property of inertia or rigidity, that is called principle of rigidity and principle of precession. These are the two important properties of a flywheel, and you can yourself see it practically whenever you find a open bicycle wheel with axle. Just hold it by both hands in like this. This is the X, this is its axle. Just hold it by both hands here and here, and ask your friend to give it a rotation like this. When it is rotating at a sufficiently high speed, try to turn it. You will find a very significant phenomena taking place here. When you try to turn it by applying a couple like this, and its effect will come one just 90 degree after that, and you want to topple it horizontally, keeping this axle vertical. You want to make this axle vertical, but it will turn like this. This is called the principle of precession. Okay. Similarly, again one more property important is that it will resist with a tremendous force any change its state or position. And this phenomena of principle of rigidity is utilized for artificial horizon or gyroscopic horizon. Why? What is this? Then we will discussing this now in details. This is the gyroscope. Here it is the spin axis. This is the spin axis. This is this yellow color is the flywheel. This is the one flywheel, and it is being acting on this gimbal ring. Then one more gimbal ring, and then the third. There are three gimbal rings. Gimbal rings. These rings can freely move about its axis, and this is the one inside the box. When you rotate this, it will hold a position. If you go on tilting this box, you want to rotate this box like this or like this or any way, किसी भी तरह से इसको rotate करेंगे, the wheel will maintain its position as it is. It will not change its position. It is freely rotating on its axle, spin axis. So, if this gyroscope is kept on an aircraft somewhere inside it, so it can decide by referring this, with reference to this, we can check the position of the aircraft. If it is rolling or climbing, this is climbing now, going upward, pitching up, pitch up, we are calling pitch up. This is a pitch down, nose down tendency, nose up tendency. Then it is rolling and climbing, it is again pitch up. These are various positions. That it is turning, making a turn, banking and turning. It is just similar to you when you drive a bike. You don't, when you on a turn, what you do? You just tilt your body, and the bike gets an angle and you get a turn. But you don't rotate your axle. You are not turning your handle. If you are trying to turn the handle, you will just skid out. You will fall down. So what you are doing? You are tilting your body a bit. Similarly, this is happening here. Here it is getting nose down tendency, pitching, it is rolling. Means you can say if this is an aircraft, this is rudder, this is flap, aileron, similarly that side also, aileron, flap, rudder, this is elevator or stabilizer, like this. Now, this is your vertical axis. A rotation about this is called yawing. Y-A-W-I-N-G, yawing. This is your longitudinal axis. This is your longitudinal axis. You see this aircraft now. This is its longitudinal axis. A rotation about this is called rolling. Similarly, this is its vertical axis. Rotation about it is called yawing. Similarly, this is your lateral axis, and rotation about it is called pitching. All these motions can be referred through the artificial horizon. If you consider a situation, a fighter aircraft flying over Delhi or Jaipur at a height of 2 km in the night, and it is taking some aerobatic sorties because it is a fighter aircraft. It has to do all the nonsense in the aircraft, in the air. And if in the night, in the dark black night, the pilot will feel that the sky is at top and bottom both are, because at the bottom there are thousands of street lights and other lights, and at the top there are stars. So he will get confused. He will get disoriented if he is flying head down or head up. And if he is flying at 1000 km per hour at 2 km height, and if he thinks that he is flying head up, and whereas he is head down, and he pulls the control stick, he will reach on the ground within a fraction of a second. The game is over. So, for him to get out of this disorientation, this artificial horizon plays an important role. It refers the position of the aircraft with the flywheel or wheel of rotation of the gyroscope, and say that it is at what angle, it is vertically down or head up. So it is a very important machine, equipment available for the aircraft to decide for the pilot if he is flying in horizontal or flying or head down position. Now again, ship or boat stability. Again, the tendency, I told you that there are two important properties of the uh, flywheel, that is of the inertia, basically the principle of precession and principle of rigidity. Again, this is the box. This is the box kept here, fixed here. You will find this boat, high-speed boat, it is just flying on the surface of the water. So if it is not there, it will, on any disturbance, due to some water disturbance, it will get drowned inside and it will sink. This tendency is stopped by this boat stability. It is having two wheels which are rotating. One is on this axis and other one is on this axis, and they will not allow the boat to get destabilized because of their property of precision and rigidity. Again, this is the inertial navigation system. For a missile system, intercontinental ballistic missile, which is going beyond 2000, 3000, 10,000 kilometers, these are first, it is going in the outer space, and then from there it is hitting the target vertically upward, and then hitting the target where they are going to. To navigate it to the exact location of the target, this again system is called inertial navigation system. It is also utilizing these principles of moment of inertia, that is principle of precision and principle of rigidity. Similarly, now the technology is changing, but in earlier aircrafts there used to be a navigation system for the aircraft also. What they do, the aircraft is parked in certain direction, and then every this meter it moves on the ground or in the air is computed by the computer, and the distance and the direction are referred by the initial parking position of the aircraft. That was a navigation system for the aircrafts also. So for you, all this lecture was because you should get interest in this subject. That's why I took these topics especially for you, that this is a very important property for an engineer. Now being a civil engineer, you should get recognition again for the area or section moment of inertia. In case of structure, area moment of inertia is the inertia of area or section, and the bending moment is the countering agent. Means it counters the bending moment. More the moment of inertia, more it will resist the bending of the structure, and or more it will resist the bending moment, it is going to counter. Moment of inertia about an axis, more will be the bending moment required. More is the moment of inertia about an axis, more will be bending moment required to deflect or bend the structure about the axis. The area moment of inertia is a geometrical property of the beam and depends upon on a referred axis. Now again you can see here, this is a flyover, these are the beams. You can find this beam is of I section. You can refer this. This is similar to this. These are similar to this. Otherwise, this is normally it is usually of this section. This section construction is difficult. On the normal sites, but these in these days these beams are manufactured and at a special site, and from there they are being transported to the site of construction, and there you can they are able to maintain the atmospheric conditions also, which are most suitable for the manufacture of these beams. So they are getting more strength. This is the cross beam, yeah, to tie these horizontal beams. They are kept on simple supports for to take into the effect of the thermal coefficient of expansion due in the summer and thermal coefficient of contraction in the extreme winters. These are the sections. This is I section, this is the U section. There can be T section, which is like this. There can be X section. There can be box section. Box section means it will be like this. There can be circular section like this, hollow circular and solid circular. This is the beam, this is the column. For the column, these rings are called tie here. Here for this it is called, this is the rings. These are again real world situation, practical examples. This is the metro track kept on a column with overhanging beam. Both two tracks, one is going for this side, other one is going for that side. This is the construction again of a building. You can find the depth of the beam is much higher than its cross-sectional dimension. Then when we are dealing with the formula derivations of I section, T section and rectangular cross sections, then we will be telling why this is important. This is the river bridge, long bridge. Now factors affecting, okay. The mass moment of inertia of the body is independent of its angular velocity. It depends upon position of the and orientation of the axis of rotation, shape and size of the body, distribution of mass of the body about the axis of rotation. The area moment of inertia, it depends on cross section area of the member. Geometry of the section, this is the geometry. This is the I section geometry. This is the channel section or U section. Similarly, there can be T section like this. There can be Z section like this. So, there can be rectangular section like this. There can be a circular section like this. So, geometry of the section and the distance of the outer fiber vertical to the reference axis. For example, this is the cross section of a beam. Then if this is your axis of reference, then this is the outer distance. If this is B and this is D and this is we will call Y. So Y equal to D by 2. Distance of the outer fiber from the centroidal reference axis. Thanks for watching this video lecture. Next 2 videos we will be dealing with the formula derivations and numerical problems.